Hey guys, my name is Manaka and I welcome you back to my YouTube channel. And as you know that I am your tutor, and today I want us to do the rivet connection. Last time we did the bolt connection and today I want us to do the rivet connection, right? So we have a question that says figure 1 above shows two plates of a steel water tank connected by means of steel rivets. Two 14mm thick steel plates are joined by means of single riveted lap joint. The pitch of the rivet is 48mm and the rivet diameter is 18mm. The rivet hole diameter is 20mm. The load carried by the plate is 80 kN per double pitch of the width. Now they say calculate the maximum allowable stress in the joint. Right, so someone, when he or she gets into this question, someone may skip and move to the next, but I am here and I want to help you to not skip the question when you jump into it. Right now you will read the question and be like, I don't know where to start, I don't know what to do, let me just jump the question, I'll come back, knowing very well that you won't come back to it because you don't understand it. So what you need to do is to understand the figure, understand the question first. Now when you read this question, you don't have any clues, right, what to do, but the question says calculate the maximum allowable stress. Now in the bolt connection, we calculated all the different types of stresses. We have shear stress, we have compressive stress, we have tearing stress. Now this is what you are going to do. You're going to calculate the shear stress, you're going to calculate the compressive stress, and you're going to calculate the tearing stress. After you've calculated them, you are going to choose the one that is the maximum allowable stress, right? So we are going to start by calculating the shear stress, which is number 1. Number 2, we are going to calculate the compressive stress, and number 3, we are going to calculate the tearing stress. So let's start with number 1. Let's calculate our shear stress. Okay, so you're going to have number 1 here and calculate the shear stress. Right, now you know the formula for shear stress. We have the load equal to pi d squared, you divide by 4 times the stress times number of bolts, right? But on this one we don't have bolts but rivets, so we are not going to calculate number of bolts, or we are not having number of bolts, right? So you might as well cancel this one out. So you don't have number of bolts in this question. On the shear stress, on the compressive stress, or on the tearing stress, you do not have number of bolts, right? So the formula for shear stress will be load equal to pi d squared divided by 4 multiplied by the stress. Now moving forward, you would want to make this one the subject of the formula, right? I hope you can see that right there, right? You would want to make this the subject of the formula. So you are going to divide this side and this side by pi d squared divided by 4, right? And we have pi d squared divided by 4. Also on this side we have pi d squared divided by 4. Now this will cancel that and that will cancel that, right? And now you have this, which is fs equal to this one here, load divide by pi d squared. Now if you divide again by 4, it will look weird or complicated, right? So let's move this 4 and bring it here like that. It's simple this way, but if you want, you can just complicate things and just put it there, right? And you're going to substitute this. You're going to have Fs equals to, now the load, we are given the load as 80 kilonewton, so you have 80 here times 10 to the power of 3, and you divide that, or you have times 4 by pi. Okay, this is pi, right? D, we have two diameters, right? We have the rivet diameter, which is 18 millimeter. We have the rivet hole diameter, which is 20 millimeters, right? So mind you, we are dealing with rivets, we are not dealing with bolts. So in this case, we are going to consider the rivet hole diameter, which is 20 millimeters. We are not to consider the rivet diameter, which is 18 millimeters. No, you're going to consider the rivet hole diameter, which is 20 millimeters, right? So here you're going to have 20 squared, and you punch this on your calculator, not the whole thing. We are not on the answer yet, so you're gonna have to have, excuse my English, but you're going to have Fs equal to 80 times 10 to the power of 3 divide, you punch that on your calculator, and you're going to have 1,256,637,061, right? Don't forget the 4. Now you're gonna punch the whole thing on your calculator, and you're going to have Fs equal to, you punch that on your calculator, you're going to get 254,648 MPa. This is your shear stress. You are done with number 1. We move to number 2. We are going to calculate the compressive or compression stress, right? So on the compressive or compression stress, we have a formula of Fc, which is the load, equal to D times T times the stress. We don't have number of bolts, right? So we leave it there, and you're going to make this subject of the formula. You're going to divide by D times T. Also on this side, you divide by D times T, right? This will cancel that, and you are left with compressive stress equal to load divide by D times T, right? And now you substitute. You are going to have the compressive stress equal to the load, which is 80 times 10 to the power of 3. You divide that, you have 20 times T, 14. This 14, it is the thickness of the connector plates that are joined in a lap joint form, right? So let me show you quickly. This is the lap joint connection. So this is the thickness of the plate. These two plates are joined, are lap joined right here, and they are joined by this single rivet here, right? So the thickness of the plate here, it's 14. Now you know where I got the 14, right? Right, we move. Now you're going to have the compressive stress equal to 80 times 10 to the power of 3. You punch that on your calculator and you have 280, right? Now to the answer, we have the compressive stress equal to, you punch the whole thing on your calculator and you are going to get 285,714 MPa, right? You are done with the compression or compressive stress. We move to the last one, which is, so this one was number 2, right? We move to number 3, which is which is tearing stress. Sorry about that. Okay, to the tearing stress, we have Ft, which is the load, equal to, we have B times T, right, minus N into D times T. You close that and you have Ft, right? You have Ft here. Now you're gonna want to make this subject of the formula, right? So you divide this side and this side by B times T minus N D times T, right? Also on this side you write that. I don't have the space to write it, but you write that. And here, guys, you should be careful because on the exam they will want to see you writing that here, right? So make sure when you write, you make space for this thing here. Don't do like I did, right? We move. Now we made this subject of the formula, and it's Ft equal to load divided by B times T minus N D times T. Now you're going to substitute. You have Ft equal to, you have 80 times 10 to the power of 3. You divide that by B. What is B, right? Let's go back to the question. Right, this is the question, or this is the scenario here, right? And I want to go to this part here, here, where it says the pitch of the rivet is 48 millimeter and the rivet diameter is 18 millimeter, right? So that B part is the pitch of the rivet, which is 48 millimeters, right? So on that B, you're going to substitute it by 48 millimeters, right? And guys, I made a mistake. You do consider the number of bolts. Yeah, right. You do consider the number of bolts, but don't worry, everything we did is correct so far. We just need to clarify the number of bolts. So because we are not dealing with bolts, but on the formula we have numbers of bolts, so on the numbers of bolts you substitute with 1 because we are not dealing with bolts, right? So here, instead of cancelling this, so do not cancel that, right? Do not cancel that, just substitute this with 1. Okay, so now here, meaning you're going to have times 1, right? Also here it's times 1, that's times 1. The answer will end up being the same as that, but I just wanted to clarify that do not cancel the end part. We do consider the bolts as 1 because we don't deal with them, but the formula deals with them. So we need to just, use our heads and minds. So the number of bolts there is 1. Let's move. Also, even here you have times n, right? Let me just write it. You have times n, and here it's going to be like that, right? And here you're going to have times n, right? Here you're going to have 1, right? And the answer still the same. Now we are here. I was talking about the B part, which we found it to be 48 millimeters, right? Times T is still the thickness of the connector plate, which is 14, right? And we close that. The end part we have 1, right? D we have 20 times 14 again, right? And we close that, and we are going to punch this on the calculator. So here we are going to have FT equal to 80 times 10 to the power of 3. You divide that, punch that on your calculator. You're going to get 392. Now you punch that, the whole thing, on your calculator. You're going to have FT equal to 204,082 MPa. Right, now you are done calculating your shear stress, you are done calculating your compression stress, you are done calculating your tear stress. Now we want the maximum allowable stress in the joint, right? So from here, you're not going to calculate anything more further. You're just going to choose between the shear stress, the compression stress, the tearing stress. You're going to choose which one is the maximum allowable stress. So as you can see, on the shear stress we got 254,648, right? Now on the compression stress we got 285,174. now on the tearing stress we have 204,082, right? Now you're going to check which one is less between the 3. You have the shear, you have the compression, you have the tearing. So between these 3 things, these 3 stresses, which one is the smallest, or which one is less? So the less or the smallest one is 204,082. So meaning this one is the maximum allowable stress. Now you're going to write underneath your answers, therefore the maximum, right, allowable stress in the joint is 204,082 MPa. Okay, and just like this we are done. So when you see the question paper, when you see this question on a question paper on your final exam, you don't have to skip it. You just need to understand the question. You just need to understand the figure, the difference between bolt and rivet connection. That's that, and you're gonna be able to calculate. Right now you have this, you have your answers, and I will see you on the next video. So make sure you like, you subscribe. Oh, and thank you for watching this video. Mwah.